So today we're going to have a look at finding independent events in probability. More specifically, finding whether an event is independent or not. So we've got a couple of rules written up here. So these first two rules here are essentially the same rule, just depending on whether we're finding for probability of A, probability of B. We just have to switch up this first section here, depending on which one we are finding. The probability rule on the bottom here is slightly different. So we'll go through that one second, but all three of these rules do have, do tell us whether two events are independent or not. So the first rule here, we've got the probability of A given B is equal to the probability of A. So if these two values are equal to each other, that means these events are independent. And the same down the bottom here, so the middle one here, we've got the probability of B given A is equal to the probability of B. So we just switch these two around here, depending on whether we've got A or B. So let's go on to the second one now. So this last one. So the other way we can find whether events are independent or not, we look at the intersection, probability of the intersection. So of A intersection B. If that is equal to the probability of A multiplied by the probability of B, then that is also an independent event. So let's have a look. We'll use this first rule for our example here. We'll do two examples, one for this top rule and one for this bottom. Let's go with this top one first. So we've got our data set out into a Venn diagram. It should come up on the screen in a moment. So here we go. We've got that data on the Venn diagram here. So we've got our A circle on the left here and our B circle on the right here. And remember, this one here falls into both A and B. We've also got two values outside that don't fall into A or B category. So what we're going to do now is have a look at finding whether these are independent or not when these two events. So let's start off by, if we remember that rule, it's the probability of A given B has to be equal to the probability of A. So let's find the probability of A first. So we've got our 3 and our 1 here, which we can add together, which will give us 4. So let's go here, probability . Okay, let's try that again. That didn't really work very well. Let's hear probability of A is equal to, so we've got our 4, that'll be on the top, and there's 10 data values. So it'd be 4 out of 10. So we've got 10 values that fall into the 10 category, but into the A category, but we've got 10 values in total. So 4 on 10, which can then also be simplified to 2 on 5. So now what we need to find is the probability of A given B, which means finding the probability of A given that it is also a B value. So we look at all our B values first. There's 5 B values. It means 5 is going to be our denominator. But only one of those B values is also an A value. So 1 is going to be on the top here. So remember our rule, it's P probability of A given B is equal to the probability of A then they are independent values. Because, let's go here, 1 on 5 is not equal to 2 on 5, then our answer here is that these two sets of values are not independent. Dependent. ENT. And I run out of space there, not independent. So now if we go on to our next one, let's have a look at using our second method. So we've got the same values here. So let's use our second method to confirm whether or not we are independent or not independent. Just check whether we got it right. So our second rule was the intersection of A and B. So the probability of A intersection B is equal to the probability of A multiplied by the probability of B. So if the probability of A and B multiplied together is the same as the probability of the intersection of A and B, then these events are independent. So let's find the probability of A and B first. So we'll start up the top here, probability of A. So if we have a look, we got 3 and 1, 4 out of 10, which we know from our last example. And we simplify that down to 2 on 5. So we didn't really have to do any working out for this because we did it in our last example. Let's have a look at the probability of B. So our probability of B, if we've got 5 B values out of 10, which then we can simplify to, let's go again, probability of B equal to 1/2. And let's make that a bit neater. Let's just put that up here. Probability of B is equal to 1 on 2. So I've got our probability of A, probability of B, let's put them in different boxes. And now let's find out A intersection B. So there's only one value in the intersection there, so that's our 1. So probability of A intersection B is equal to 1 out of 10 values in total, 1 out of 10. So now let's rewrite this formula here with all of our values in there. So probability of A intersection B is 1 on 10 equal to probability of A is 2 on 5. And multiply by 1 on 2. When we multiply values in, do the top 2 multiplied together, bottom 2 multiplied together. So then let's move that over. Does 1 on 10 equal 2 on 10? No, it doesn't. So 2 on 10, and it doesn't equal. So let's say it's not equal to, which confirms what we got in the first example. So 1 on 10 is not equal to 2 on 10, which means that these values are not independent.